So there we have it. We've got power going to our circuit, and if I press one of the two, and why is it doing that? Okay, so last night I got so carried away opening up the hacker box and just diving right into the D flip-flop that I didn't do anything with the AND gates and the OR gates. So tonight, build a couple of circuits with these guys, and then build an AND gate out of transistors and resistors, just to see how you would make that with just a transistor, because I mean, we're almost at the bottom, so we might as well just go right to the bottom. Okay, so this is going to be the 7408, the AND gate, and the power input pin is the same for all three of the chips. Pin 14's V voltage common and common collector, and the ground is pin 7. So that's all we have to really keep an eye out for. And then for an AND gate, basically you have 3 pins in each corner of your device. So 1, 2, 3, 4 corners. And yeah, A, B, and out, A and B. So we're going to put in some 100 ohm pull-up bleeder resistors for the LEDs, and set up a couple of LEDs for the input lines and an LED for the output line. So pin 3 on the device is the output line, as you see right there. So I'm going to hook that up to this LED, and so the output line will go high and low depending on what inputs are coming in on pins 1 and 2. Alright, so I'm going to stop here for a sec and update on progress. The pins 1 and 2 are going to go to a push button that is going to pull those pins either high, or then otherwise they're going to be isolated, so they'll be at low. But we should actually try and figure out a way of grounding them so that you can definitely not leave it floating. So you either ground it or you bring it high to give it a signal. And since it's a little hard to see on here, what we've actually got is our chip with these 3 pins active in this corner. This is the output. This will be A, and this will be B. So the output is actually A and B. So that pin and that pin have to get hooked up to a couple of switches that you can take to +5. And that will give you a 1. So, to show what is actually going on that pin, remember we have a light emitting diode that we are going to connect through 100 ohms to ground. So what we're doing here is we're creating a simple current divider, voltage divider with this resistor. There will be some input impedance in this pin here, so you can think of there being a resistor here. So you've got a voltage divider, some small amount of current will go through here, illuminate this when you bring the this pin high. And then similarly, we do something for line B. We put a switch in for it, then it goes to +5, and then on the other side another resistor and an LED connect it to ground so that when this pin goes high, we'll be able to see it with a LED. Alright, so we got the other switch in and the rest of the wiring in. So once again, power supply from last night. Anything above 7 is probably going to work. I've got it plugged into 12. So minus goes to the minus rail. Plus 5 regulated goes along here, but also to pin 14. Pin 7 is connected to ground. We've got pin 3 connected through a 100 ohm resistor to an LED to ground. When pin 3 goes high, this will light, 5 volts, and then when pin 3 goes low, this will turn off. These two are showing the status of the signal coming into pins 1 and pin 2. Pin 1, pin 2. Power comes into this switch. When it gets pressed, it goes high. This is wired incorrectly. That should be over there. That is why you walk through your circuit building as you go, to catch mistakes like that. Power is on this rail. This switch is this guy here. So this power lead comes in here. It goes to this pin of the switch, and that's the switch part there. So it makes contact between these two when you depress it. Or press it. When you do that, you're bringing 5 volts to this lead here, which is pin 1. So pin 1, pin 1. Bringing 5 volts there, but you're also bringing 5 volts to this resistor, which comes down through your LED. Sorry, my finger's in the way. The 5 volts that comes up through here and out of here goes to your resistor, through your resistor, and down to ground. And then the same thing on this side. Plus 5 comes in here. When that goes high, the blue wire is going to pin 2. And when that goes high, that also brings this resistor and this LED into play. So, yeah, that's that. All right, so after replacing the power supply, things got a little more stable. And actually correcting the circuit, things got a little more stable. You've got pin A going high and low, pin B going high and low, so A and B, those were connected to pins 1 and 2. And since it's an AND gate, Since it's an AND gate, the only time you're going to get an output is when both A and B are hot, live. So if B stays high, A goes up and down, up and down, up and down, it follows. Up and down, up and down, up and down, it follows. Until there are both pressed, in which case it stays high. And if there's just a low on one side and a high on the other side, it does not change. The only time it does is when you've got both high. The only time you'll ever see all 3 LEDs lit is when these 2 buttons are pushed at the same time. AND gate. So, the truth table, nothing in, nothing out. 1 in, nothing out. 1 in, nothing out. Both in, 1 out. So, I'll probably write that down. 0, 0, 0, 1, 1, 0, 1, 1. A, B, out. Or let's call it A and B. 0, 0, 0, and 1. If there's a 0 in A and B at all, it's a 0. But if there's no zeros, it's a 1. And then remember last night, not A and B was, okay, so symbol for this. This is an AND. The not AND has a circle in the front. And this is A, B. Take A and B, but take the opposite. So the truth table is the opposite of this one. Anytime you've got a 0, it's going to be a 1, except when you've got 2 1s, in which case it's a 0. So it's 1, 1, 1, 0 for the same 4 cases. 0, 0, 0, 1, 1, 0, 1, 1. And an OR gate works much the same way, except instead of a and, it's or. So here's A, B, A, or B is one way of writing it. A, B, A, or B. 0, 0, 0, 1, 1, 0, 1, 1. Are either of these high? No. Are either of these? Yes. 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 0, 1, 1, 1. So that's the truth table for the OR gate, and then the NOT OR is the reverse of it. So the NOT OR, which would be the A or B, NOT, is the reverse. 0, 0 would go to 1. 0, 1 goes to 0. 1, 0, 1, 1. A or B, actually NOT. So we write those two truth tables in the same table, and we could have done the same thing over here. So yeah, that's AND and ORs. And not ANDs is enough to build actual logic circuits that can store information. So it doesn't take very much of these in order to actually get something useful to happen in a computer. If only we could implement it somehow. And the next thing I wanted to do was to try and figure out if I could wire up a little transistor logic gate to see how that works. So what we're going to use for this is some perfectly ubiquitous transistors, NPN bipolar transistors, 2N 3904s or H331s, or I think there's a B22 number that is like, they're all just generic NPN transistors. If you don't have any specific requirements for them, they're just switching line voltages. There's no high frequency stuff you're doing or anything like that. Just for switching, you can totally use them. So this is what an NPN transistor looks like as a circuit diagram, and I'm going to explain a bit about how it operates. So you've got this thing here called the base. Let's just, for now, trust me, that's what it's called. It's usually drawn in a little circle. The base is in the center here. And then you've got a line coming out this way, and these are the other 2 pins of the transistor. It's a 3-pin device. You call this pin the collector, you call this pin the base, and you call this pin the emitter, because it operates this way. If you've got a small amount of current flowing through into the base and out the emitter, just a small amount of current, when it gets past a certain point of current, it will trigger this as if it were a switch. And so whatever potential you have up here, say it's 6 volts or something like that, or 5 volts, even if this was a tiny voltage, with a tiny bit of current, like 0.01 volts, as long as it's above the threshold of this switch, producing whatever, with a resistance, it'll produce some sort of current. As long as it surpasses the threshold of this switch, it will allow all of this to flow. Whatever you've got up here, plus 5 volts, however many, up to the failure limit of the device. So if you've got like an amp and this is less than an amp and rated, you're going to blow it. So it'll just let whatever you've got up here pour through. That's why some people like to think of it as a valve, because you can turn it on and off and control a huge flow. Some people think of it as a switch, and some people think of it as an amplifier, because maybe both of these signals are coming from the same power supply, and all you're really worried about is what's coming out of the emitter. So if you modulate your base voltage, you can modulate your output voltage. And this output voltage is going to be proportional to this, not to, well, it's going to be related to this, not to this. So that's why you think of it as an amplifier. You've got a small amount of information going in, you get an amplified version of that information coming out. Amplifier. So as a switch, if you're just worried about just flowing, and if you don't want to modulate this thing, but if you want to modulate it, you can think of it as an amplifier. That's a transistor, NPN. So now, on these devices, we have to figure out which one is the emitter, base, and collector, so that we can put it into a circuit in a sensible fashion. Taking a look at the data sheet tells me that pin 1, if you have the flat up, pin 1 is to the left, and that's the emitter. So if we are looking at it sort of like this, with the pins coming out, that's pin 1. And that's the same thing as the emitter. Pin 2 is the base, and pin 3 is the collector. So pin 1, pin 2, pin 3, emitter, base, collector. So emitter, base, collector. Emitter, base, collector. So it almost makes sense that that's what the circuit diagram indicates. You know, okay, think of that as the flat. You've got your collector and your emitter coming out of the bottom, if you look at them from the top. That's the way I'm going to remember this particular one, but check the pin out on every device that you put in, just so that you don't make a, well, don't be like me, kids. I've drawn the circuit that we're going to implement, and we can talk a bit about how it works later, but just what it actually does. We've got two inputs, A and B, and an output, and I'm claiming that this thing will behave as if it is a AND gate. So why don't we just implement it on the breadboard and see if it actually works, and then try and figure out how it works once we see if it works. Okay, so we've got our two transistors located on this side of the breadboard, and we've got emitter, base, collector stacked up like that. So we're going to be hooking up collector. Base is going to be either going high or low, so we'll have a switch that goes to the positive rail. Then we'll also, and probably put an indicator LED on that as well. And then same thing here, we'll put a switch to power with an indicator LED on this pin. And then coming out of the out, well, I have to do a my little resistor network here. So that is 4.7K to ground, and the output is coming out of that pin. And I just ground that through a 4.7K resistor. And so that'll be the output there. So we'll see. And so that's what I'm going to pull my LED off of to through ground, or sorry, through a resistor for the LED, and then down to ground. And that will give me the indications on all of my input lines. Okay, so we're starting to build it up a bit here. Right now we've got our collector up here. So that makes this our emitter. Our emitter is connected to our collector of our cascade transistor, and then on the output leg, the emitter leg, that's going through a resistor. Well, I should probably... Okay, emitter of my output line is now connected to ground through a 47K resistor. Yellow, purple, red. and that pin is also connected through a 100k ohm resistor and an LED to the ground, so that if current does appear here, most of it will go that way. Most of it will go that way, some will go that way. But in any event, when this pin's high, this will be lit. And then I've got to configure these switches so that when this base is high, or this base is high, I've got an LED that will illuminate based on the status of those bases. Okay, so this guy, collector, base, emitter, 3 pins all in a row. So I've got the collector up here, that's going to be tied to high, and it's going to be a switch into here. So this is the base. So the base is going to, I need to tie this high, or this high. This high, because when this is brought high, this base, that's going to be line A. And when this base is brought high, that's going to be line B. And same sort of thing. So I just move this jumper back so that it ties the emitter of this transistor to the emitter, the collector of this transmitter through here. So that goes pin 3, and then jumpers across there up into pin 4, 5, 6. So that's how that part works. And then taking the output there, we did all that before, so I just have a couple of things to hook up to power, and we're ready to roll. Okay, so we wire the collector of our top transistor directly to power, and then remember we've got A and B connected to either VCC or not, and it's going to have a 10K resistor that is pulling it either high or low. On the other side of this, we've also got a LED. That is giving us an indication of whether or not this thing is live or not. So if this is high, sorry, should have drawn it off of here. If this is high, then you'll get a voltage current divider effect here, and you'll see whether or not this is a voltage, and same thing here. If this is high, you'll see that it's got this LED lit, and then we'll see what happens when we connect our output LED on this end. Yes, I had picked poor values for the resistor. The resistor that was attached to the LEDs was sucking off too much current, because now we get what we expected for an output. Only when you press both buttons do you get an output. And I'll pick some better values for the resistors here so that we can see what's going on. But yeah, it only works when you press both buttons, and AND gate out of transistors. So here's the theory of operation of this thing. Remember, this thing switches on if you've got a voltage here or some current. So we've got a big resistor, a small amount of current will flow if this is brought high. That means that this can flow, so we'll get a high voltage here. Otherwise, we've got 0 here. We've got VCC when this is low, VCC here, 0 here. When this is high, we've now got VCC here because all of this is flowing through our resistor, our transistor. And if this comes high, then all of the electricity can flow through this switch, and it'll come out here. And the way I implemented it, I put also a little resistor to an LED light emitting diode so they could see when we actually had voltage here. So I have to adjust these values because I think that's what's going on there. And same thing, I'll think about where these resistors are, because I might also have my my LED on the wrong side of this. So in any event, if you have a 1-1, you get an output. 1, 1 gives you an output. But if either of these are 0, that means either one or both of these switches is off. So no current is flowing. So 1, 0, 0, 1, and 0, 0 all lead to a 0 output. So there you go. That's your AND gate. A, B. Actually, let me write that down with something you can actually see. A, B, and output, which is equal to A and B. Whoops. So 0, 0, 0. Neither of these switches are on, so nothing's getting through. 0, 1. One of the switches is on, but one of them's off, so nothing's getting through. Just because you changed it to the other switch of the two switches doesn't mean that anything's going to get through until you change it to both of those switches are on, in which case something gets through. So there you have it. That's the two transistors implementing an AND gate. There's also an easy way to do a not AND gate with another transistor, and that's how you get logic circuits out of just plain old transistors. Okay, those are going through a lot of resistance. You can barely see them illuminating, but they are.